So finally, we're going to finish up vectors here, and we're just going to talk about vector operations. So when vectors are used in math expressions, the operations are performed element by element, which is maybe perhaps not what you're expecting. So if we have a 6 by 1 vector x, and then we create a new vector y, which will still be 6 by 1, as we see below here. What is happening? Well, we're taking the first element squared, so 16 plus 1 creates 17. Then the second element squared, 49 plus 1 creates 50, and so on. So we see that squaring will just element by element square that value. Then if we multiply, take the product of x and y, we also see element by element multiplication. So 4 times 17, 68. 7 times 50, 350, and so on. So be aware that this is the case for vectors in R. Here's a few other, this might be useful just to print out the single slide and use as a reference for common vector functions. And so these generally do operate best on vector objects in R. They can be applied to matrices, which is what we're going to talk about now. But we'll talk about how to do that properly later on. But these work and are designed to work specifically on vectors as they're coded in R. So matrices, it's just a two-dimensional generalization of a vector. Here's a command, script command to create a matrix. You can enter the data, or you can just enter NA if you want to create a matrix structure to be filled in later. You can specify the number of rows, number of columns, specify whether or not the data here gets entered by row or by column. The default is by column. And finally, the length of row and column names, if so chosen. So for example, to use each of these options in the matrix command, we can create a matrix as it appears down here. Notice we have elements 5, 6, 0, blah, blah, blah. Because we have by row equal true, those elements are entered by row. So notice the first 4 go into the first row. The next 4 go into the next 4, and so on. If we had by row equal false, then we would have 5, 0, 6, 1, 3, 5, and so on. Then let's see, we have the number of rows and columns specified, and we also have the names for the row and columns, C1 and R1 and so forth. If we want to reference specific elements of a matrix in R, it's pretty much the same as it was with vectors. That's why I said we need to lay the foundation with vectors first, and then we can understand the rest of this fairly simply. Notice when we print out the X, and this was out without any labels on the columns or rows, we can see that the first element in the first row and first column is 5. And this is exactly how we would make reference to that element 5, in fact. So for example, second row, third column is 9. Well, let's go to the second row, third column, and we get the element 9. So notice you just use the brackets as we did for the vector, but you divide the row and column number by a comma. If you want to obtain a specific row, you just name the row before the comma and then leave the column blank. Similarly, if you want to pull out a column, you leave the row blank and specify a particular column. If you want to get a set of columns or a set of rows, you can create a vector. See, notice this is the concatenate function, and we're creating a vector 1, 3, which picks up the first row and the third row out of our matrix X. The column dimension is left blank, so we get all the columns. We can also reference them using row and column names, but often matrix objects do not have it, so you can't always use that. Sometimes it's better to use this row column. For example, if a program adds or permutes columns of a matrix, then your numeric index of the columns may change. So you may end up referencing the wrong column of your matrix if you use an old index number. But if you appropriately name your columns, then you can always just use that reference to the name. reference matrix objects using the square brackets that you have to use quotation marks in place of your index number. If you have a matrix and you have yet to define names for the columns and or rows, you can use the call names, row names, or dim names function. And so A is a matrix, and you just create a character vector on the right-hand side so that you can name those columns or rows or dimensions. You can also name the elements of a vector itself. So for example, this concatenate function contains the expression name1 for 1, name2 for 2, and then you can use the function names to name those vector elements. Here's some examples of what I was just talking about in theory. Here's a matrix N, okay? Here's what N looks like, the contents of it. Here we use the call names, so we're going to create column names for N. The call names are going to be C1, C2, C3, and we can see that take place right here. Notice we did not create row names, so we're still just using the indexing notation with square brackets. Then, if we want to make reference to C2, we use the same square brackets, but we put in quotation marks C2. If you leave off those quotation marks, it will not be able to recognize that because it is understood as a character string within R. If we want to make sure we know the column names of a matrix, you can just run the call names command. So notice here, this use of call names lists out the column names of N. This use of call names combined with an assignment statement created column names in the matrix. Then, if we have another matrix, such as M, we can actually bind these together by column so that we get the following. So notice diag2, I haven't introduced you to this function in particular yet, but it's just going to create a 2x2 identity matrix. You can see that right down there. And then we're going to bind them. So we have M column binded with N, so we can see them placed right next to each other. So now we have a 2x5 matrix in MN. Okay, then we can make reference to specific elements of that MN matrix. For instance, the second column or the column name C2. And it will retain those column names or not retain column names if there are none created. Okay, so a few about matrix operations. Operations are again performed element by element, just like vectors. If you're going to do matrix multiplication, you need to use a special multiplication operator, and that is the asterisk surrounded by percentage signs. If a vector is used in a matrix multiplication, it'll be coerced to either a row or column, whichever makes it conformable. Okay, so it will assume that you want it to be conformable. So you have to be very careful about that, actually. Using this operator on two vectors is actually going to give you the inner product. And if you want the outer product, that's the operation. Okay. And finally, we can convert any inner product or any thing that we get to a scalar variable by just using either the concatenate or as vector. Okay, an example, A and B, okay? A times B just does element by element. So notice A, think about, maybe run this, stop this, make sure you can recognize what A and B look like, and then note that it's doing element by element wise operations. Then if you use the matrix multiplication operator here, why is it different? Make sure you understand the difference. Bring that question to the discussion board or class if you have any questions about it. Finally, also, if we create a vector y, we can do an inner product here on y. So this would be 14. Make sure you understand where that comes from. And then we could run, if we wanted to run an expression like this, where we divide a matrix A by the inner product, it's going to give us a error because it's saying you cannot do matrix division because these are non-conformable. This is technically a 1-by-1 matrix here. But if we run that inner product through the concatenate formula or make it a vector, i.e. make it a vector, then we can do that division. Okay, to wrap up this part of the video, here's a few matrix functions. Again, just like the vector functions, I recommend printing this out and keeping this as a reference. This is good to have if you forget particular things such as, oh, how to find the inverse of a matrix. It makes sense why it's called solve, but that you may have not thought of that at the outset. It also gives you help about how to use particular functions as well.